So for question 9, same reaction at time 0, right? We know the concentration of nitrogen, we know the concentration of hydrogen, we know 75 seconds, what that is. Okay, how much nitrogen has changed after that 75 seconds? So I'll actually jump back to the previous page because we need this rate of hydrogen to answer question 9. And we're going to use that to basically find out the rate of nitrogen as a result. So the rate of nitrogen, right, we're going to do the same thing, just use those coefficients to find the rate of nitrogen. And then we're going to say, well, nitrogen reacts for 75 seconds to get what's the concentration of nitrogen that's consumed. So we know based on these coefficients, right, 1/1, the rate of nitrogen would equal 1/3 the rate of hydrogen. And that's a negative, and that's a negative because they're both reactants, they're both being consumed. So we plug in the rate. We'll just leave that as negative. Rate nitrogen equals 1/3, 1.4 times 10 to the minus 3 for hydrogen. And so we're back to that 4.89. .89 times 10 to the minus 4 molar per second. So we'll divide by the -1, divide by the -1. The rate for nitrogen is 4.89 and negative 4.89. Molar per second. All right, got the rate of nitrogen. Now we want to know how much nitrogen has changed after 75 seconds. So actually the first time I was working with this question with a student, I thought it was asking for like the final concentration, like how much nitrogen was left, but it's actually just asking for the change, right, as it reads. So to do that, all we have to say is, well, okay, the rate is 4.89 times 10 to the minus 4 molar per second, and that reaction runs for 75 seconds. So when we multiply this by 75, we're going to get the change in concentration. And don't forget, it's a negative rate, so it's a negative change in concentration as well. So let me get that times 75, and I get like 3.7, a negative 3.7 times 10 to the -2 molar would be our change in concentration of hydrogen, or so of nitrogen for question 9. Does that make sense, Sean?